dear student, I welcome to you in my video lecture. Myself Professor Ashok Thumar. I work in Department of Mechanical Engineering at Dr. Subhash Technical Campus. Today's chapter, and that is chapter number 1, Introduction of Mechanism and Machine, that we are going to discuss in this video lecture. As a part 1, whenever I have uploaded previous video, the same chapter will be discussed as a part 1, and this video lecture will cover remaining portion of the chapter Introduction of Mechanism and Machines. Before going on the various mechanism and to have the discussion on it, it is very important to learn the term kinematic chain. Basically, it is defined as the combination of kinematic pair in which each link forms a part of two kinematic pairs, and the relative motion between the links is either completely constrained or successfully constrained. That means if the pairs, or we can say that the kinematic pairs of which every link is connecting with two kinematic pairs, and the relative motion, if you are finding that either completely constrained or successfully constrained, then we can say that it is a kinematic chain. Now look at the figure. It shows a kinematic chain with three links AB, BC and CA, which are pin joined at the point A and B and C. And in this case, there will be no any kind of relative motion is possible if each link forms a part of two kinematic pairs. So kindly focus upon three links AB, BC and CA. So ultimately all links which is related with each other, having the no relative motion is possible unless and until there will be no any kind of pairing of the kinematic pairs. So a combination of three links form a structure, and due to not any kind of relative motion, there will be not considered as a kinematic chain. But if you are finding similar mechanism or say kinematic chain in which especially four kinematic pairs are given, and there will be a relative motion in between, of course we can say that it will be nothing other than the kinematic chain. So in conclusion, we can say that in order to have the kinematic chain, each link should form a part of two kinematic pair first, and there should be a relative motion in between the links. Suppose you have given any mechanism, especially in which there are four numbers of links, and each link satisfies the two conditions of the kinematic pairs, formation of kinematic pairs, and of course they have the relative motion. Of course we can say that it is nothing other than the kinematic chain. So based on the above discussion and from the figure, there is a relation between the kinematic chain, and that is n is equal to 2p minus 4, j is equal to 3 by 2 into n minus 2, and j plus capital H by 2, that will become 3 by 2 n in minus 2. So where in case of the first equation, n stands for the numbers of links, that means through this equation you can determine the numbers of links which are connected in entire mechanism, whereas p stands for the numbers of lower pair. So ultimately the mechanism which contains the numbers of lower pair, you can easily calculate by using that relation too. J stands for the numbers of joint, and H, that means the numbers of higher pairs which are available in the mechanism given to you. So in short, we can say that any mechanism can be said to be kinematic chain whenever it satisfies the two conditions. Each link should form the two turning pair which is joining with that link, and secondly each link has the relative motion with each other. So this is the prime condition through which you can identify whether the mechanism or the links form a kinematic chain or not. Now it's time to discuss the various types of joints in a kinematic chain. There are basically three types of joint that generally used to form a kinematic chain, because we required a joint to connect or assemble the different links which are used in various mechanism. So binary joint, ternary joint and quaternary joint are the three basic types of joint which are widely used in case of assembling of various links. So if we are talking about binary joint, then when two links are joined at the same connection to form a kinematic chain, that joint will be known as a binary joint. Look at the diagram. If you are finding that there are two links which is connected on same point, or we can say that on same fulcrum, that fulcrum point or the, simply that particular connecting point, that will be known as a binary joint. If we are talking about ternary joint, then when the three links in place of two links, if you join by any joint or any point on same connection to form a kinematic chain, we can say that it is ternary joint. Look at the figure in which specially there are the point E and C. If you are looking carefully at this mechanism, on especially this is the joining point E and C. So by carefully watching, you can conclude that the point E is joining three links, basically EC, EA and ED. Similarly, you focus on the point C. Then also point C is also connecting three links, namely EC, CB and CB. So we can say that these points or connecting points are generally referred as a ternary joint. After that, there is a quaternary joint, and in place of now three connection on same point, if you are linking and assembling the four links on same point or same locator, of course it will be known as a quaternary joint. Look at the diagram exactly below given to the quaternary joint, and focus upon the point number, actually observe the point, this one or rather this one. So in that you can see that this point is commonly connecting all four links. So over here this is the case in which, or this is the point through which we are connecting four links on the same point. So we can say that this point or this joint, basically it is a quaternary joint. Now point number 3 is the difference between binary link and binary joint. After a discussion on binary link and binary joint, now it's very easy to have the differentiate both of binary link and binary joint. If you are thinking about the binary link, then it is the link which can join in mechanism at 2 points called binary link. Whereas in case of a binary joint, when two links are joined on the same connection to form a kinematic chain, that particularly joint is known as a binary joint. So this is the little bit difference between a binary link and a binary joint. Generally, in simple way, we can say that binary link are joined at the 2 point, whereas binary joint is the joint through which we can have the assembly of the two links on same point. Now, very much discussion on kinematic chain and pair. Now it's time to discuss on closed and open kinematic chain. Look at the figure. Kindly consider a kinematic pair which have the two links, link 1 and 2, and one more pair that consisting of the links 3 and 4, and one pair that contains the link 5 and 6. So basically you have to consider one entire kinematic pair, or say the kinematic chain in which the links 1, 2, 3, 4 and 5, 6 that are being connected to each other. Actually, name gives the meaning of this type of chain, closed kinematic chain. That means it is a closed loop which is formed by joining a numbers of kinematic pairs in such a manner that each link is connected to more other links. So if you are finding any mechanism, or say the combination of various links in which each link are connecting with each other and forming a closed loop, or say the closed circuit, it will be known as a closed kinematic chain. And But in case of closing of the last link, if the last link of the kinematic chain is not joining to the first link, then this chain will be known as an open kinematic chain. So look at the bottom side diagram. You can compare easily both of the kinematic and open kinematic and say the closed kinematic chain. This is the closed kinematic chain. You can see that each link is connected with each other, and last link is of course connected with the first link. So this forms the closed circuit, or say the closed loop. But if we are talking about open kinematic chain, then kindly consider this diagram, in which you can see that there is a one fixed link which is connected with another link, and in that way you have the connection at the end. But the last link, or the point one last link, is not connected with the initial link over here, so we can say that it will be the open kinematic chain. Still, you can classify a closed kinematic chain in two categories: simple closed chain and a compound closed chain. If we are discussing on a simple closed chain, then when the chain consists of only binary link, there will be only one closed loop. Such condition, or if the chain is there, it will be known as a simple closed kinematic chain. That means the kinematic chain which consists only binary link to form entire closed loop, we can say that will be the simple closed chains. But in case of binary links, if you are using ternary or more kind of the links and joining the entire assembly of links, and which look like a closed loop, of course it will be known as a closed chain. So this is what about the closed kinematic chain and open kinematic chain that we have discussed. After that, the point number 5, that is mechanism, and this term we have listened a number of times. So basically a mechanism is a kinematic chain with any one link fixed and which is used to transmit required motion. This is what about a mechanism. Especially there is a kinematic chain, one link is fixed and which is used for the transmission of motion. The assembling of the linkage will be known as a mechanism. Generally a mechanism with 4 link will be known as a simple mechanism, and the mechanism which has more than 4 link will be known as a compound mechanism. And one more thing that you should to note, that in case of different links of kinematic chain which are fixed, the result is the different mechanism. Suppose that you have given 4-bar chain mechanism and you are fixing one by one each and every link, there will be different mechanism at the end you are getting. For example, suppose there are 4-bar chain mechanism A, B, BC, CD, D and D, and of course EA. So if you are fixing each link one by one, then every time the mechanism performs the different role. So we can say that by fixing every link you are getting the different required output motion. Such a phenomena, or we can say that the mechanism that we are getting by doing so, that will be known as an inversion of a mechanism. So when such a mechanism generally used for the power and motion transmission, it will be generally we term it as a machine. So now, after discussion on basic concept behind the mechanism, it's very important to discuss here in the how many kinds of the inversion of kinematic chain, or say the inversion of mechanism that you are getting by fixing each and every link. So if you are fixing any one link, then entire mechanism will become a frame. When the different links of a kinematic chain are used as a frame, the relative motion of various links are not altered. So the absolute value of motion of such a mechanism will be it will be altered, or we can say it will be the chain. So the process of choosing different links of a chain for the frame is shown. Generally we can say that it is the kinematic inversion. That means if you are selecting every link, each link for the required output from the kinematic chain, that will be ultimately known to kinematic inversion. So The behavior and appearance of such a mechanism will be of course different because we are changing the fixation of each and every link. So basically you can get the numbers of inversion, numbers of type of kinematic chain, but basically for the subject point of view there are main three types through which you can classify the inversion of kinematic chain. Look at the diagram. Most important types of the inversion of kinematic chain, that is 4-bar kinematic chain. Second type you can have is a single slider kinematic chain, and third one is the double slider kinematic chain. If we are talking about 4-bar kinematic chain, then it has 4 turning or say the revolute pair, whereas in case of single slider crank chain it has 3 turning or say the revolute pair and 1 sliding pair is there, and in case of a double slider crank pin it has 2 turning and 2 sliding pair. So this is what the little bit difference between each and every types of say the kinematic chain. From the figure you can easily identify that look at the diagram, 4-bar kinematic chain, it has the 4 turning pair, or we can say that the revolving pair, because over here it can be rotated over here too. In that way all 4 location has the turning action. So that's why the 4-bar kinematic chain has the 4 turning pair. If we are talking about the single slider kinematic chain, then we can say that it has basically 3 turning pair, and of course one will be the sliding pair. So similarly you can also have the analysis and the calculation of numbers of the sliding pair and turning pair in case of double slider kinematic chain. Now various discussion on the link arrangement. It's time to discuss the types of inversion of 4-bar kinematic chain. And the first and very much important inversion that we are going to discuss, that is coupled wheels of a locomotive. And basically in this type of inversion, if the links 2 and 4 generally, or any 2 links are made equal length or in 4-bar kinematic chain, we are getting a double crank chain which is used generally to transmit the motion from one wheel to another wheel. Look at the diagram. Over here we have make 2 link having the equal we can say that the length or radius, and by fixing one link permanently and rotating this link in any direction as an input, you are getting the output motion of link 2. So this is the concept through which we can have the output motion, and this concept basically used in especially locomotive vehicles, wherein we require to transmit the driving wheel motion to the driven wheel motion. So you can see from the figure that link 1 is fixed, link 2 and 4 are rotating links. It will work like a crank, and link 3 acts as a lever which will be the auxiliary during the motion and power transmission. Now after that the second type of inversion that we are getting from the kinematic chain inversion, that is the beam engine. Generally function of this mechanism is to convert the rotary motion of the crank into oscillatory motion of lever, and finally from the oscillatory motion of lever to reciprocating motion of piston. So in this mechanism when crank rotates about some fixed point like point A or point O, the lever will oscillate about the fulcrum point or some central point, and by using additional linkage, that means piston and cylinder assembly, you are getting the reciprocating motion of say the piston. So this is how we can have the application of beam engine. After that, third type of inversion, that is the Watt's engine indicator, or we can also say that double lever mechanism. Now if you are looking carefully, this Watt's engine indicator mechanism generally based on 4-bar chain mechanism, in which link we can say that any one link is fixed, link 2 is we can say that the ABC link, link 3 is CDP, and both acts as a lever or oscillator, and link BE and link ED will form a link 4. So in that way we can have the assembly, And ultimately, if you are looking carefully, then link BF and link FD both are connected with say the piston and cylinder assembly. So when you rotate the link AC in a particular any direction, due to this linkage of AC with other links, ultimately the point F, or say the link which connect the point F with the piston and cylinder assembly, it will of course oscillate, or say they move in upward and downward direction. So over here we have the connection of piston to this link. So ultimately piston will also reciprocate in up and downward direction. So at the end of the lever CDE, there is a link and which connects the common point F to the piston. And if you are giving them any motion in any direction, either clockwise or anti-clockwise, at the end you are getting the reciprocation motion of a piston which is reciprocated inside the cylinder. And last inversion of a kinematic chain, that is Watt mechanism, and generally it is also based on 4-bar chain mechanism, and it is specially used to trace an approximately straight line. So this is the very specific application. You have given that 3 link which are connected with a common point pinpoint P with each other, and consider a common point or common contact point P over here, and if you are applying a rotational motion to input link in any direction, either clockwise or anti-clockwise, this link will rotate in any direction. So the intermediate link which is connected with the initial link will get oscillate like that. So whatever the point P that is present on intermediate link will trace look like curve. In that manner it will trace the path. So ultimately we are getting the required tracing point, or we can say that tracing path at the end. So dear student, this is what about the few inversion that we are getting from the kinematic chain. Just you have to select the fixation of each and every link. On the way of by doing so, by adopting the process of this fixation of various link, you will have various types of inversion, and based on that various types of inversion that you are getting, you can use all the inversions of mechanism on a very specific application site. So this is what about the basic detail about the various inversions. Thank you very much for your kind of attendance to my video lecture. Thank you.